another form of the differential equation which appears very regularly in real life is what's called a linear form. A linear form of the differential equation. Say dy dx plus p times y equal to q, where p and q are functions of x. P and q are functions of x. That is, p a function of x and q a function of x. P a function of x and q a function of x. This form is called a linear form. It's called a linear form. It's called a linear in y. It's called a linear in y. It's called a linear in y. Let me give you the solution to such forms, the result of which you want to remember eventually. What I do is I multiply both sides with e power integral p dx. Yeah. These two p's are same, of course, right? Now, realize what's the derivative with respect to x of e power integral p dx? What's the derivative of e power integral p dx? E power integral p dx if you differentiate with respect to this, and integral p dx if you differentiate with respect to x, that will give you p. ddx of integral p dx will be p. Integrate and then differentiate, you will restore the function, right? You know? So, this fellow realize that what is this? This is y ddx of e power integral p dx. See, you have p e power integral p dx, p e power integral p dx is ddx of e power integral p dx. Yes or no? Let's samjhate. Don't worry. ddx of e power integral p dx. Chain rule, I'll apply chain rule to differentiate this. E power t with respect to t. So that's e power integral p dx, right? And then differentiate this with respect to x. You integrate something and then differentiate that, you get the same thing, right? You'll get p. So this is e power integral p dx into p. Yes or no? That means this p e power integral p dx is actually ddx of e power integral p dx, right? This second term. The first, do you all understand everything that I have said here? And the first term is dy dx into e power integral p dx. Yes or no? And the right hand side is q e power integral p dx. What do you say? Are you all comfortable with this? समझ में आया? Right? What do you think this is going to be? Derivative of first function into second function plus derivative of second function into first function. Y is one function, e power integral p dx is second function. Y is one function, e power integral p dx is second function. Derivative of y into this plus derivative of this into y is derivative of the product of two functions. Is derivative of the product of two functions, yes or no? So this is like y e power integral p dx. I'm sorry. This is d dx of y e power integral p dx equal to q e power integral p dx. Yes or no? Got me, na? Nahin. I multiply by dx throughout. Shine, with your permission. Shine takes objection to all this. This is so far okay, na? Okay. Right? Integrate both sides. This would be y e power integral p dx equal to integral q e power integral p dx dx. This will be the solution to this differential equation. This will be the solution to this differential equation. Linear in y e power integral p dx, y e power integral p dx is integral q e power integral p dx dx. This from here to here, this is derivative of the product of two functions d dx of, what is the left hand side? This is d dx of y e power integral p dx equal to q e power integral p dx, right? This dx, integral dt will be t, na, which is y e power integral p dx, and this will be integral q e power integral p dx. Got me? That's a solution to this linear equation. Let me illustrate this a little bit. Look at the sheet, you know. Let me solve a couple of problems on linear differential equation so that you don't feel tremendously cheated. We'll just a moment. I'll write down the problem on the board anyways, Parthu. Yes, of course you have to remember this. 100%, yaar. You have to remember this. And by the time I solve 2-3 problems, you'll automatically remember all of this. Not an issue. Can I wipe this off? Say, look at problem 1 of part D. Problem 1 is 1 plus x square dy dx plus 2xy minus 4x squared equal to 0. And let me write down the solution to this equation so that you can have a ready reckoner. Y e power integral p dx is integral q e power integral p dx dx. Yes or no? That's a solution to this kind. Now, this I want to convert in this form. I divide throughout by 1 plus x squared. So dy dx plus 2x by 1 plus x squared into y, p into y. I take this on the right hand side is 4x squared divided by 1 plus x squared. Right? So this is my p. Dy dx plus py equal to q. Yes or no? Dy dx plus py equal to q. It exactly matches with this formation. Right? The solution to this differential equation is going to be what? Y e power integral p dx. This is integral q e power integral p dx dx. That will be the solution to this, right? So the solution to this differential equation is y e power integral 2x by 1 plus x squared dx p dx. Let me obtain this on the margin. Integral 2x by 1 plus x squared dx is log 1 plus x squared. Yes or no? Is log 1 plus x squared. And e power integral log 1 plus x squared, e power log 1 plus x squared is what? 1 plus x squared. Yes or no? Do you realize? E power integral this. This is what? This is log 1 plus x square, numerator the derivative of the denominator. And e power log 1 plus x squared would be 1 plus x squared. E power log 1 plus x squared would be 1 plus x squared equal to q. First I put an integral sign and then I put a q. Q is this. 4x squared by 1 plus x squared. And then whatever I have obtained for this, e power integral p dx. E power integral p dx is what? 1 plus x squared. Isn't it? E power integral p dx is 1 plus x squared. We have already obtained. So this is into 1 plus x squared dx q into e power integral p dx. E power this is 1 plus x squared dx. Yes or no? Good for us. And this is y into 1 plus x squared equal to integral of 4x squared, which is 4x cubed by 3 plus c. Yes or no? That's a solution to this differential equation. Order 1, how many arbitrary constants? 1 arbitrary constant. Yes or no? Let me solve a couple more. Second one is exactly the same, so let me take some other. Let me look at problem 3. dy dx plus y tan x equal to x squared cos squared x. Is it a linear form? Dy dx plus py equal to q, where p is a function of x, this is my p, and q is a function of x. Yes or no? Linear form? So I can directly use this result. So first of all, y e power integral tan x equals q, which is x squared cos squared x e power integral tan x dx. Yes or no? Integral tan x is what? ln constant यहाँ पे नहीं, constant at the very end, right? Integral tan x is log mod sec x. Is log mod sec x. So I get e power log mod sec x, just write sec x, and e power log sec x would be sec x. Yes or no? So this will become y sec x equal to integral x squared cos squared x into sec x dx. Yes or no? X square cos x is all that you need to integrate. How do you integrate that? By parts. X square cos x you can integrate by parts. Right? You'll have to do by parts twice. X square will first reduce to x, and then x will reduce to 1. It will not happen in one shot. Do you realize it will not happen in one shot? X square cos x. When you integrate by parts, you'll have to deploy integration by parts twice. X squared into integral cos x sin x minus integral 2x sin x dx. Yes or no? Stage 1. Stage 2, you'll have to apply integration by parts a second time to this, right? So that's going to be x squared sin x minus twice x into integrals of sin x minus cos x, and then plus integral cos x derivative of x, which is 1. Integral cos x would be sin x, and you would have gotten this right. Right? Yes or no? I'll have to take more sessions on indefinite integrals with you. Right. Nevertheless, you understand. Let me solve a few more. I just want you to get used to this. Can I wipe this off? Hmm? Number 4. Look at this, x plus 2y cubed dy dx equal to y, say. Where on earth is it linear, you know? It doesn't seem like it's falling in this category at all. It's not. It's not a linear in y. God damn it. It's not a linear in y. Trust me, it's not a linear in y. Why? Can you convert this into this form? Cannot. But if you keep your eyes and ears open, look at it with love and affection. This will be like dx dy equal to x by y plus 2y squared. So far so good? Yes or no? If you divide it by y, dx dy is x by y plus 2y squared. Yes or no? Now, dx dy plus minus plus, say, minus y x equal to 2y squared. Yes or no? It's a linear in x. It's a linear in x. Where p is minus 1 by y, p is a function of y and will be minus 1 by y, and q will be a function of y and will be 2y squared. Yes or no? It's a linear in x, not a linear in y. Do you realize it's a linear in x? Instead of y, we have x. Dx dy plus x into a function of y equal to a function of y, right? So solution to this differential equation is going to be, so if I had, say, a linear in x, which is dx dy plus x p into x equal to q, where p is a function of y and q is a function of y. You don't have to reinvent the wheel. What you want to do is, the solution to this differential equation is going to be x, instead of y e power integral p dy, p dx, x e power integral p dy equal to integral q e power integral p dy dy. That will be the solution to this differential equation. क्या नहीं है? X and y interchanged, and p and, so instead of dx appearing everywhere, you have dy's appearing everywhere, and p and q are functions of y instead of being functions of x, right? So I have x e power integral p dy p is minus 1 by y, dy equal to integral q is 2y squared into e power integral minus dy by y into dy. Yes or no? Integral minus 1 by y dy is what? Is log 1 by y? Is log y, which is log of 1 by y. So I have e power log 1 by y here, minus log y, so log 1 by y, which is 1 by y, So I have x by y equal to integral 2y squared into 1 by y. And when I integrate this y, I'll get y square by 2. Y squared by 2 plus a constant of integration. So x equal to y cube by 2 plus cy. Do you realize that? 2y, when I integrate, I get y square. Y square, I get y square. Sorry, y squared, y square. So y square plus c. So x would be y cube plus cy. X would be y cube plus cy, where c is an arbitrary constant. This was also a differential equation of order 1, and therefore only one arbitrary constant. Yes or no? Let me illustrate a little more. So you know, you need to check sometimes if dy dx doesn't work and doesn't fall within the jurisdiction of a linear in y, it's likely that dx dy will be a linear in x. You'll get a linear in x instead of getting a linear in y. Right? Can I wipe this off? Let me solve another one for you. Say sec squared y dy dx plus x tan y equal to x cube. Hey, it's neither a linear in x nor a linear in y. What on earth is it? It's neither a linear in x nor a linear in y. This I can sec square y dy I can write as d of tan y dx. Yes or no? Yes, plus x tan y equal to x squared. I'll take tan y equal to some z. I'll take tan y equal to some z. It'll become a linear in z. Linear in tan y. It's a linear in tan y. Yes or no? So dz dx plus z equal to x squared, where p is this, a function of x, and q is this, a function of x. It's a linear in z. Yes. Huh? I mean, I don't. Someone. Some problem in the sheet. Check that out. It's there. It's there in the sheet. You want me to tell you exactly where I picked this problem from in the sheet? I'll tell you. E2 x cubed. Okay, let me. He's saying x cubed. Let me. It will not make a difference. X cubed, if you like, yeah. I'll make it x power 4 also if you want. I don't have a problem. It will not complicate matters for me or for you. Okay. Now the solution to this differential equation is going to be what? Z e power integral p dx. Integral x dx. Right? Integral x dx equal to integral x cubed e power integral x dx. Yes or no? X dx dx. Do you realize whatever I've done here? No. This is e power x square by 2. Z e power x square by 2 equals x cubed e power x square by 2 dx. What will you do? So you're right. This I can write as x squared e power x square by 2, and 1 x dx will become d of x square by 2. Do you realize what? I broke it up into two, x squared and x. X square you see here, the other x dx, I wrote as d of x square by 2. Yes or no? The other x dx, didn't understand, no? Huh? Got me, no? You lost a little bit? No? Now it's simple. It's like half integral t e power t by 2 dt. Yes or no? X square is t, t e power t dt. Yes or no? And if you want to make t by 2 the subject of integration, do this into 2, 1. You could have made t by 2 the subject of integration, isn't it? Do you realize how I did that? So this will be like twice integral z e power z dz. Z e power z dz, where z is t by 2, where z is t by 2, yes or no? Lost kya? Nahin? How do you integrate this? No, I will not. If you like, you integrate by parts. But yes, you can integrate by parts. Huh? So, integral z e power z dz. Z power z. Boop. I could have written this as z minus 1 plus 1 dz. So e power z fz plus f dash z. Fz plus f dash z. Right? So this will be e power z into z minus 1. Yes or no? You could have done this. E power z fz plus f dash z. E power z fz. Right? So easy to integrate. So essentially, you know, what I did was a form of this kind. Some f dashed y dy dx plus fy into p equal to q. This is the form. So f dashed y dy was d of fy dx equal to p fy plus p fy equal to q. It's a linear in fy. It's a linear in fy. You can take fy equal to z. It will become a linear in z. That's the form that we got exposed to. Right? Yes or no? Let me illustrate a little more. Okay. Let me first introduce a form so that that's a form, it's not required, but you know, it will eventually be another manifestation of this very form. But can I wipe this off? So now the form that I'm going to be talking of is this. Plus py equal to q y to power n. That's the form that I'm going to be talking of. P and q are functions of x. Functions of x. P and q are functions of x. Do you realize that the linear form was only a special case of this? If you plug in n equal to 0, it will get reduced to a linear form, isn't it? If you plug in n equal to 0, you will get the linear form, isn't it? So the linear form will only be a special case of this. Right? It will require no special treatment other than doing this. I multiply throughout by y to power minus n. Equal to q. Now, y to power minus n dy is d of what? Y to power 1 minus n divided by 1 minus n? Yes or no? D of y to power 1 minus n dx plus p y to power 1 minus n equal to q. Y to power 1 minus n. So it's a linear in y to power 1 minus n. Do you realize that? It's a linear in y to power 1 minus n. So you can take y to power 1 minus n as some z. So this is like by 1 minus n. This 1 minus n I missed out. 1 minus n. I multiply throughout by 1 minus n. So I have d of y to power 1 minus n dx, right, plus 1 minus n into p y to power 1 minus n equal to 1 minus n into q. This is what I get. Multiplying throughout by 1 minus n. And then you take this as z. So I have dz dx. And the new p becomes p into 1 minus n. The new p becomes p into 1 minus n. P into 1 minus n z equals 1 minus n into q. The new p is 1 minus n into p. The new q is 1 minus n into q. And same form, it's a linear in z. You can get going with this. Yes or no? It's reduced to a linear form. Yes or no? This form is reduced to a linear in z. And this form is called the Bernoulli's form. This form is called the Bernoulli's form. Oh, কি করে এলো? Okay, z e power integral p, which is 1 minus n into p dx, equals integral 1 minus n into q e power integral 1 minus n into p dx dx. Got me? That'll be the solution to this differential equation. Right now? That's the Bernoulli's form. That's the Bernoulli's form. dy dx plus py, instead of being q, is q into y to power n. N need not be an integer, by the way. Right? Let me illustrate something from here. Can I wipe this off? Now look at this form. Look at this form. I seek to reduce it to Bernoulli's form. Chill, man, chill. dy dx is y into y log x minus 1 by x. That's dy dx. Right? And then I could rewrite this as dy dx. This minus y by x I transpose on the left hand side. Y by x equal to integral equal to y squared log x by x. Yes or no? dy dx plus py equal to q, which is this, into y to power n. Right? I'll multiply throughout by y to power minus 2. I'll multiply throughout by y to power minus 2 so that I can make this 1. Right? So y to power minus 2 dy dx plus this will become 1 by y into 1 by x, right? Equal to log x by x. Right? And this would be y to power minus 2 dy is what? D of y to power minus 1 divided by minus 1. Right? Okay. So when I do that, minus d dx of 1 by y plus 1 by y 1 by x equal to log x by x, right? Minus, I multiply, equal to this. So it's a linear in 1 by y, linear in 1 by y, where what is p? P is minus 1 by x. What is q? Minus log x by x. It's a linear in 1 by y. So the solution to this linear in 1 by y is 1 by y e power integral p dx. P is minus 1 by x dx equal to integral minus log x by x q e power integral minus 1 by x dx dx. Yes or no? When I integrate 1 by x, log x minus 1 by, right, log of 1 by x e power, log of 1 by x would be 1 by x, log of 1 by x would be 1 by x. So this will become 1 by xy equal to this will become 1 by x dx. Nahin? Yes or no? It would have helped the matters if it was x. 1 by x squared log x doesn't really help too much. You realize what I'm saying? It would have been really nice if it was 1 by x, because then log x, x and x would have got cancelled. I would have had log x, which would be x log x minus x, right? So I'm just checking if there is, because log x by x looks incongruous. Let me check if I have y log x, y squared log x plus y by x, y to power minus 2 minus 1 by y. No, I'm just seeing if, sorry? No, but then there is this 1 by x also sticking out, d log x. But so let me see if this can be integrated. Let me check if this can be integrated. So essentially I'll have to integrate log x by x squared. All right. So obviously you want to differentiate log x and integrate 1 by x squared. You want to differentiate, so it shouldn't be a problem, because this would be log x into integral 1 by x squared, which is minus 1 by x. It's okay, it's pretty all right, plus 1 by x, and derivative of log x is 1 by x dx, right, which is okay. So minus 1 by x log x minus 1 by x is what you'll get. Yes or no? Which is okay. It would have been better if there was an x here. It would have saved us some work. I was hoping that happens. Didn't happen, but nevertheless, log x by x squared I have integrated by parts. Log x into integral of 1 by x squared is minus 1 by x. Integral of derivative of log x 1 by x, and then minus 1 by x will make it plus 1 by x. And then integral 1 by x squared would be minus 1 by x, which is all right. Not too much of a bother. Right? So this is what happens. So this is essentially then Bernoulli's form. This is Bernoulli's form. Clear?